Hello and welcome to SewerGEMS Learning. This is Ahmed from Egypt and you're watching me through my YouTube channel. In this video, I'll talk about the design constraints and by the ways the SewerGEMS can make the design or analysis of the sewer networks. And without the design constraints, the SewerGEMS can't make the design of the sewer networks. Okay, so the design constraints has two kinds of categories here in SewerGEMS. The first one is the global design constraints. We can call it the global design constraints because it's applicable for all the elements in your model. Okay, if you enter some values in the design constraints, SewerGEMS called it as a design constraints, it will be applicable for all the elements in your model. But if you want to change some constraints for some elements like some conduits or some manholes, it will be specific, so we can call it the local constraints. In this video, I'll talk about the global design constraints and how can we treat with it, okay, and what is the values you can enter it, and some definitions for every parameter in the design constraints. Okay, we'll go to the tab of analysis and choose the design constraints as you see from analysis tool. A new window is opened as you see now, and it's called the default design constraints. The default design constraints has three elements as you see will have the design constraints. I'll talk about the gravity pipe in this video, and I'll talk about the node design constraints in another video. And I will not talk about the inlet because it's related to the storm network, and here in my videos or my course I concentrate on the sewage or the sewer network design. Okay, so we will talk about the gravity pipe constraints, the default constraints. As you see, it has four parameters. Now I'll talk about it step by step. The first value or the first constraint type is the velocity constraints. Okay, without these constraints, the design will not be made. Will not be made. Okay, will not be done. Okay, and the velocities you can specify it. For example, the velocity minimum for preventing or to prevent the sedimentation of the matters in sewage in your network, and the maximum velocity to prevent the scouring of the pipes. So every country, every code or standards has limitations for the velocity minimum and maximum. This is, we can call it the minimum velocity, we can call it the self-cleaning velocity. Okay, a lot of codes or standards have a value, for example, 0.6. Most of them have 0.6. Another codes have a value of 0.75, I think. So every country, wherever you are, will depend on your code or your standards on this value. Okay. The maximum velocity, most of codes and standards have limitations of it. For example, 3 meters per second. Here in Egypt, 1.5 meters per second. It's most of countries in Arab countries, GCC codes and standards have limitations of 3 meters per second. This is for plastic pipes, HDPE, PVC, PU-PVC. But for ductile iron pipes, for example, it can be more than that. You can reach it to 4.6 meters per second, I think. Okay, and this is according to ACCE. By the way, the velocity constraints type have two options, symbol or table. It's very rare to make it as a table, but I think I saw it in some codes as a table. For every rise or for every diameter has limitations of the velocity minimum and the velocity maximum. You can use this type of table to enter these values, or you can make it as a symbol and either it for many times as a symbol, 0.6 and 3 meters per second for the conduits. Okay, and the second parameter is called the cover, and the cover is the distance between the ground levels or the finish levels, pavement or dirt roads, the ground level to the pipe crown. Okay, so here you have two choices or two options: measure cover to pipe soffit or pipe crown. What is the pipe soffit and what is the pipe crown? What does it mean? I'll go to the print and draw. I'm sorry for this circle. It's not a circle. We can use it as a circle. Okay. So this is the pipe. The pipe shape is as a circle, and I'll make another. Okay. This is the thickness of the pipe. We call this level the pipe crown, and the inner level here is the soffit. This level is the pipe soffit. So if you enter to the catalog that you made in this SewerGEMS, the thickness of the pipes, the inner diameter is different from the outer diameter, and you enter the thickness, so the pipe soffit here is different from the pipe crown. The difference between them is the pipe thickness. Okay, so you are obligable to make it the cover measure to the pipe crown. Okay, but if you enter the values of the inner diameter equals the pipe outer diameter, so it's the same, similar. Okay, so you can choose whatever pipe soffit or pipe crown, it will be the similar. Okay, so here I'll choose, for example, pipe crown, and cover constraint type. You can make it also like velocity, symbol, or table. We always make it as a symbol. Okay, and the cover minimum to protect the pipe from the traffic loads is about 1.2, 1.2, 1.3 in some standards, and 1 meter, for example, for some roads without traffic loads, high traffic loads, 1.2, for example, in other roads, and 1.3 in some roads and standards, as I said. So I'll go with the 1.2, for example, and here the cover maximum, it's about the maximum cover you reach about after going downstream, I think, because it's in the upstream, it will have the minimum cover or a less or a lower cover. But in some cases, you can reach high values in the upstream of the networks that depend on the circumstances that you have in your design. So the cover maximum is the maximum cover you reach wherever you are located in your network. Okay, in some codes, and most of codes, that value between 6 and 8 meter, because after these values, the digging will be higher in cost will be higher absolutely, and the digging construction tools will be required in some soil types. So in this case, you can go with the pump station and pump the sewage to upper or less sufficient value, and start again your network from the minimum. Okay, to the cover minimum, cover maximum, for example, I'll enter it as 6. Okay, going back to consider cover along pipelines, I didn't forget it, by the way. Okay, if you want to make a check here to consider cover along pipelines, you'll be required to active your terrain model. If you remember my video about the terrain model, it will be shown here now. You can remember it through the link. You want to, or you will be required to active your terrain model and choose it from. What does that mean? What is the meaning of considering cover along the pipelines? Okay, going back to paint and drawn some manholes. And here is the ground level, will be something like that, and that is the pipe, and we can do the pipe. This is the pipe, this is the pipe invert, so, and this is the pipe curve level. The cover will be considerable on the start manhole or the start of the conduit, and the end manhole, the end of the conduit, because the design constraints will consider the cover along the pipeline. Okay, so it will consider only the start and the end ground levels of the conduit. So it will be dependable on the comparison of the pipe slope with the ground level slope. For example, if you have a ground level slope like that and the pipe slope like that, the pipe slope is lower than the ground level slope. The program of the SewerGEMS will consider the minimum cover here at the end manhole of the conduit. So 1.2 will considerable here, and this cover will be more than 1.2. Okay, but actually, not all the ground levels are finished. Not all of them are pavement. Okay, and if it's pavement, by the way, also it can be changeable along the pipeline or the conduit between manhole A and manhole B. It cannot be something like that. Okay, I can show you also what does I mean. I'm going here to the paint and draw something like that. Okay, the ground levels are getting lower, getting higher again. So the cover here, if we consider, we will go back to the pipe. If we consider, we'll consider the cover minimum here in the end manhole 1.2. It will be lower than 1.2 in this point, by the way. Okay, so if you are considering the cover along the line and make the terrain model activated, okay, the program of the SewerGEMS will consider 1.2 here in this point and putting the pipe with the minimum cover here. So the cover here will be more than 1.2 and will be more than 1.2 here also. Okay, I think it's clear. Going back to SewerGEMS, and I think it's enough today to explain the cover constraints and the velocity constraints of the gravity pipe constraints, and I'll complete the other constraints of the gravity pipe with the explaining of the new design constraints. Thank you, and don't forget to make a subscribe to the channel and click on the bell, and see you in another video. Thank you.